We have covered some elementary programming concepts in the last lecture. We talked about rules for naming identifiers, and one important type of identifier is variable. A variable has a name and a type, which defines what type of value can be stored in the memory allocated for the variable. We talk about primitive data types, which are types that are built into Java. We also talk about expressions, especially arithmetic expressions, which allow mathematical operations to be performed for certain tasks. By combining expressions and assignment operators, one can modify the values of variables. We then discussed type conversion, which allow operations to be performed on a mixed type of data. Lastly, we introduced some simple input and output methods using the I/O class that created for this course. The use of primitive data types can be used for problems that deal with numbers and text, but many real-world problems need to deal with more complex objects than just numbers and text. For example, when we want to manipulate images and video. An object-oriented approach will allow you to design computational objects to deal with complex tasks by using the data abstraction approach that we introduced in the first lecture. If you take a look at the environment around you, you'll find many physical objects. You may be watching this video using a desktop PC, a laptop, or a tablet. You probably also have a mobile phone somewhere around you. You may be watching this video with the lights on or off. You'll find that there are two common characteristics with these physical objects. They all have their distinct states and behavior. For example, most lights can have only two states, that is, on or off, and the two behaviors would be to turn the lights on or to turn the light off. But there could also be lights that can take on more than just two states and behave differently if there is a dimmer which could adjust the lights to different brightness. Or you can even set it to a blinking state like Christmas lights. For a smartphone, it can also be in an on or off state. If it is on, its volume can be adjusted to a certain level. You can change the behavior of a smartphone by calling your friend, starting a play music app if you find that listening to music is more soothing than listening to my voice, surfing the web to find out the current news, watching some video on YouTube, or WhatsApp your friend. You'll find that all these real-world objects can be modeled as computational objects using object-oriented programming. For example, a smart light switch with sophisticated behaviors can be controlled by an object-oriented program according to the lighting condition in the room so that it can achieve energy savings. And many apps written for smartphones are object-oriented programs. In this lecture, I'll introduce the basic concepts of object-oriented programming using Java. I'll discuss the important concepts of classes, objects, and methods. Variables can be found in classes, objects, and methods. I'll also briefly talk about the scope rules on the meaning of variables under different conditions. Scope rules will be discussed in more details in the next lecture.